So this is chapter 8.4, sample test questions. Um, so let's go through those and help you understand this. The first one says, how many different three-letter words are there? They don't have to be real words, and the letters can repeat. So what I've got is I've got three-letter word. So it could be A. It could be A, B, C. It could be A, X, A, B. It could be A, B, X. That's a different word than XAB. That's abs, whatever you want to call it. So, anyways, those are my different things. So, if I have three spots, how many choices do I have for this first spot? Well, our alphabet has 26 letters, so that's 26. And since we can repeat numbers, the second spot or letters also has 26. And because we can still even repeat another one, the third spot can have 26, and I just multiply those together, and that will give me the total number of choices that I have. So that's just 26 to the third. So 17,576 choices in that. So for me, it's very helpful to say, okay, how many letters? That means I have this many spots. Okay, it's kind of like those horse races that you think of, or you hear about. You're like, I have 10 horses. How many ways are there for the top four spots? So, oh, there's four spots. How many horses were there? There were 10. If that one's first place, then this one has to have 9 spots for second, or 9 choices. I've taken out a first and a second, so that leaves 8 choices for third. I've taken out 3 horses, so that leaves 7 horses for the next one. And then I multiply those together. Okay, so uh, there is that difference. Okay, it does make a difference when order matters and order doesn't matter. For example, if I have the ABX is the same as XAB if order doesn't matter. If I'm just pulling three letters out of the 26, these are the same. Okay, and so that does change things up a little bit. Oh, I just had a thought. Um, on your calculators, this is slick. So if I go to my calculator and I hit math and I go over to probability, see this one that says NCR? So this says I'm choosing 3 letters out of 26. Whoops, I did it backwards. I have 26 letters and I'm choosing 3. That's how I was supposed to read it. There we go. So that's 2,600. And now watch what happens. Math, probability, permutation, 26, 3. Somewhere I've messed up. I figured out what I had done. This is going to work out nice, but these are saying I choose 3 letters out at a time. So I'm choosing just 3 random letters out at a time. So this is, with this, you never could get A, because you're choosing 3 letters out at a time. Whereas with this first one, you are choosing 1 letter out, putting it back in, taking letter out, putting it back in, and taking another letter out. So that's why this has more. This would work if we were doing without replacement. Okay, so if I were doing take a letter out, take another letter out, and take another letter out without ever putting it back in, then I get the same as this. So what this is this is the number of ways you can take out 3 letters together, and this is the number of ways that you can take out 3 letters together as well. But the difference is, so here's the difference. They're called combinations and permutations. So permutation, the order matters. And in this one, order doesn't matter. Kind of like I was showing with this XAB and ABX, they're the same three letters. As far as a word goes, they're different because this starts with an X, whereas this starts with an A. So if I were trying to say this was a word, that is definitely a different word than this one. It's kind of like was and saw. Those have the same letters, but they are definitely different words. Okay, but if I'm just saying, um, do they have the same three letters without any meaning? Yeah, this has the same three letters in it. It's kind of like if I want to choose um, 5 people to form a group, I could have Sally, Mark, uh, Will, Sarah, and Tell. Okay, so that would be 5 people. It doesn't matter which order I choose them out. There are 5 people in a group. Now, if I say I'm choosing 5 people and the first person chosen gets $1,000, that makes a huge difference in the order that I'm chosen because the first one gets 1,000 and the last one only gets $1. Well, I want to be the first one to be chosen. Okay, so whereas if I'm just choosing a group and you 5 are going to work together, that order doesn't matter. So anyways, that's the difference between a combination and permutation, and even in a little bit different of replacement without replacement. Okay, replacement means I put the card back in. You know, that's your marble problems. You have a bag of marbles, and you draw them out, and you have different colors, and you either put them back in or you don't put them back in. So replacement says you put them back in. Without replacement means you keep them out. Okay, you keep out your marbles and they don't go back in. So the number in the bag is actually getting smaller. And that changes the number of choices you have to choose from. Okay. So anyways, I just made that question really long, but hopefully that helps you understand a little bit more of probability. It's interesting stuff and confusing at the same time. So what is the probability of rolling a pair of dice 3 times and never getting a double? Okay, that's a little bit more. So we have 3 dice. So the first dice, it can be anything. Okay, it could be a 1, 2, 3, 4, 5, 6. Right? It could be a 1, a 2, a 3, a 4, a 5, a 6. So this next dice, uh, if this was a 1, so let's say I rolled a 1 on my first dice. This dice could be a 2, 3, 4, 5, or 6. So let's say I rolled a 2 on this dice. This last dice could be a 3, 4, 5, or 6. Okay, and that would ensure that we don't get doubles. So um, I think I made that one wrong, though. Give me a second. Let's look at this backwards instead. 1 minus the probability of getting doubles. So the probability of getting a double, so when we, remember when I had the dice and we had it like this, and we had all of this stuff, like we had a black dice and a red dice. Well, the way to get doubles, there were 6 out of 36 pairs, right? So to get doubles on one roll is 1/6 of a chance. Okay, so probability of not getting doubles is 5/6 of a chance on just one roll of 2 dice. But now we're going to roll them 3 times in a row, 3 times in a row. So what is the probability of rolling a pair of dice 3 times and never getting doubles? So that's going to be 5/6 times 5/6 times 5/6. So 1 minus that. Okay. So I go to my calculator. 1 minus 5 divided by 6 to the third. So 42% chance. So never getting doubles, you have a 42% chance of never getting doubles out of 3 rolls. Okay, which would mean to get doubles, you have a 58% chance out of 3 rolls. So, anyways, that's kind of a weird problem, but this way, this is the correct way here, but this is, I don't think, the right way here. So we can try it and see. 5 divided by 6 times 4 divided by 6. Yeah. It doesn't give you the same answers. So these questions are tricky. So when it says never getting a double, sometimes it's easier to say 1 minus the probability of getting a double. Okay, so it's easier to say what's the probability of getting doubles. 1 minus that to never get doubles. So on this question, it says the lottery is in an extremely small state, consists of picking 2 different numbers from 1 to 10. So we have 1 to 10. 10 ping pong balls numbered 1 through 10 are dropped into a fishbowl and 2 are selected at random. Suppose you bet on 2 and 9. So you bet on this one and you bet on this one. What is the probability that at least one of your numbers matches the one selected? So we have this fish bowl. So these are all inside of some fish bowl for some reason. This is a very flat fish bowl. Somebody puts their hand in here and they grab out 2 numbers. What is the probability that at least one of your numbers matches the one selected? So how many do I have to choose from? I have 10 to choose from. And I have 2 numbers. So the number of times that I could win is 2 out of 10 or 1 out of 5 chance. Okay? So at least one of your numbers matches the one selected. What is the probability that both of your numbers match the one selected? Okay? So they draw a number out. So let's say on the first draw, there's 2 ways they could get one of my numbers right. But on the next one, I've taken my 2 out. That leaves the 9. So that's 1, but I've taken the 2 out, and there's 9 ping pong balls left. Okay? And so now I multiply those together. I'm going to simplify first. That becomes 1/5. So the probability that I get both of them right is 1 out of 45. Okay. Okay, I wanted to show you, I have these 6 different ABC, CBA, BCA, ACB. These all have the same 6 letters. 3 letters. Okay, so there's 3 different ways that I can, or there's 6 different ways that I can rearrange any 3 letters or numbers for that matter. If I had 1, 2, 3, I could go 1, 3, 2, 3, 1, 2, 3, 2, 1, 2, 1, 3, 2, 3, 1. So anyways, there's 6 different ways that I can rearrange objects or groups of 3. So a way I could do that is if I have 3 spots, I could have 3 times 2 times 1, which makes 6. Okay? So when I am making groups of 3 out of the alphabet, so I could choose the first letter, I could choose the next letter, and the next letter. This is without replacement, okay? If it were with replacement, it would be this. Now, if we're saying that these are the same thing, okay, then I would divide this answer by 6. Because each one of these groups that I form, there's going to be 6 that are the same thing if ordered if order doesn't matter. So that's what our calculator does for us automatically when we do this NCR stuff. Okay, so it does that for us automatically when we do that. If order doesn't matter on this one, um, we'd have a whole lot more from our three letters because we could now have this. Okay, so that's just with the first two being A's, and then we could have ABA, ABB, ABC, and so forth. Okay, that's just, these are just A's. So anyways, losing my voice, but this would just be with A being first. Then you could have all the B's first and all the C's first. And so realize that if we're talking about just how many different orders we can make out of this, we have to divide by a lot more to do it this way. If we're just talking about how many combinations of letters, but since we said words, we didn't have to do that. But just that just gives you kind of a thought of how this works out if we're doing a combination of different things. So, okay, let's see if we can think through this next problem that says, suppose the course offerings at the University of Texas at Austin are simplified. There's only 20 classes offered. Each meets at a different hour each week in the state, meaning there's no overlapping classes. Okay, there's no enrollment limit on any course. Each student is required to take exactly 4 courses. Okay, so there are no prerequisites and every student can take any class. University of Texas, Austin has about 48,000 students. Part A, if students choose independently, how many different course schedules are possible? So let's just do, we don't need to worry about that 48,000. We're just going to say each student must take 4. So we've got 20 classes offered. Student 1 can choose from 20, and then 19, then 18, and then 17. Okay, so that's just the first one. But so that's how many choices of, of classes could be taken by one student. Okay, so this is how many they could choose, right? So they could choose 20, but realize, like, if this is math, English, science, um, art, that's the same as this: science, English, math, art. Because it doesn't say the order, we don't have any order that really matters. They just have to have 4 courses. So this 4 is the same as that 4. So what we've got to do, if students choose independently, how many different course schedules are possible? I guess that's another question we'll have to ask ourselves: is does the order matter on this? I guess is this the same schedule as this? Maybe this, or is this the same as those ones? Nice, huh? So, anyways, um, if those are different schedules, then there's a lot more course offerings. If we say these are the same, there's a lot fewer. So let's pretend that these are different. So if those are different, then we would have 20 times 19 times 18 times 17. Okay, so 116,280. So those are, if we say those are different, okay? Now, if we say these are the same, then we'd have 4 times 3 times 2 times 1. So we'd have to take this number and divide it by 24. So divide it by 24, and we'd get 4,845. So just showing you what your calculator does, 20C4 and 20P4. That was in the math probability part again. So that NPR and NCR, it gives you the same answers as what we did and just does all the work for you. This is when the order matters. We're saying that SAME was not the same as MESA MESA. And so we're saying there's a lot more choices, or if we say they are the same, there's this many choices, okay? So 4,000. So it depends on which one we're talking about, how you interpret that question. If we say that these are all different different schedules, then there's that many. So now part B. Will some students have to have the exact same program or not? Justify your answer. Well, if we're saying that these are not the same, then we have plenty of options and none of those will have to have the same class. Whereas if we're saying this is the same program, then yeah, it's roughly every 10 students, because 48,000 divided by 4,800 would be 10. Roughly every 10 students would have the same schedule. So it depends on how you viewed that. As long as you justified that, it would be perfectly fine. So anyways, that would be that. It says you have a jar of copper pennies. You want to estimate how many there are. So you take 50 steel pennies, put them in the jar, and shake the jar vigorously until all the pennies are mixed up. So you have 50 steel pennies. Okay. Then you reach into the jar and pick out 100 pennies at random. So you pick out 100 pennies at random. You find that 10 of them are steel ones. What do you estimate the number of copper pennies in the jar to be? So if 10 are steel, 90 are copper, right? So if we, depending on how you want to set this up, you could say 10 is to 90 as 50 is to X. Okay. Or you could say steel to total. So 10 steel to 100 total equals 50 steel to X over total. So I'd go, this will reduce to be 1 over 10. This will reduce to be 1 over 9. So 9 times 5 is 45, add the 0, X equals 450. On this one, I have 1 over 10 equals 50 over X. So X equals 500. But realize this is the total, right? So if that's the total, I just need to minus out the 50 still ones that I put in, and I get that there are 500 minus the 50 makes 450 copper. So it just depends on how you see that problem. Okay. Now the next one is expected value. So you spend $10 and you buy a lottery ticket. Okay. There are the following prizes. The first place is $1,000. And there's only one of those. Second place, they get $500. And there are 3 of those. There's 10 third place people, and they get $250. And there are 100 fourth place people, and they get back their $10. Okay, it says there are 1,000 tickets sold. What is your expected value in participating in this raffle? So let's go ahead and talk about this a little bit. First of all, what's the probability that you win first place? Probability that you win first place is 1 out of 1,000. And how much money do you win? You win $1,000. So remember when we talked about, so if I have a coin and I flip it 10 times, what's my expected value of heads? That would be 50%. If I have a dice and I roll it 24 times, what's the probability of any specific number? That would be 4. So remember, it's the probability times, like this was the number of times that we flipped them or whatever. So this is similar to the probability of getting this amount of dollars. Okay, so that's how we do the expected value. We say this is the probability, this is the event, the probability of this event. Okay, so the probability of getting this event of $1,000 is 1 out of 1,000. The probability of getting $500 is 3 out of 1,000 people. The probability of getting $250 is 10 out of 1,000. The probability of getting $100 is 100 out of 1,000. Okay. And the probability of this one, most people don't look at this as a probability, is 1,000 out of 1,000, and you lose $10. Okay. Everybody loses $10. And most people are like, no, but yeah, everybody loses $10. That's a sure deal. Okay. The rest of them, the probability is not so good. But that one, that's a awesome probability. So that's why this guy that's selling the tickets is like, sweet, everybody gives me $10. Every person loses $10. So now my expected value, I just add all of these together. That's all that we have to do for expected value is calculate the probability of each event, and then just write it down. Okay, so somebody's going to win $1,000. Here, let's just do this. Let's go to our calculator. 1 divided by 1,000 times 1,000 is going to be 1, right? 1,000 divided by 1,000 is 1 times negative 10 is negative 10. 3 divided by 1,000 times 500 is 1.5. 10 divided by 1,000 times 250 is 2.5. And this is going to equal 1 as well, because if I cancel off 2 of those zeros, that leaves me 1 over 10 times 10. Well, 10 over 10 cancels off and leaves me with just 1. Okay. And then if you really wanted to, you could say this is 110, 1,314, 1,000 minus 114, 886 get nothing. What are their winnings? 0. Okay, if you want, that way we have everything taken care of. We have all of the different probabilities that could exist. Because it's these guys don't. Everybody loses $10, and then you win back your earning. You win back this much money. Okay, so there's multiple ways we could do this. I'll show you this way, then I'll show you. Well, here's the other way real fast. Instead of doing this part up here, I say 1 out of 1,000 wins $990 because he paid 10 and won this. 3 out of 1,000 win $490 because we take their $10 off. So they leave $990 richer. This person leaves $490 richer because they lost their 10. These people, they leave $240 richer. These people break even. And then we have this number of people who lose $10. So now if I go to my calculator and do those, 990 divided by 1,000 is going to be 0.99. 3 times 490 divided by 1,000. 3 times 490 divided by 1,000 is 1.47. 10 times 240 divided by 1,000. 10 times 240 divided by 1,000 is 2.4. This one's 0. And 886 times negative 10 divided by 1,000 is negative 8.86. So now if I add these up, we should get the same amount. So we're going to add this row up right here. So 1 plus 1 is 2. 1.5 plus 2.5. So if I add the 0.5, that makes 3. That makes 4. And add the 2 makes 6. Add the negative 10. So negative 10 plus 6 makes negative $4. Now if I do this one, hopefully it works out the same. I just need to add those 3 to negative 8.86. So I add 2.4 plus 1.47 plus 0.99. Whoops. Negative 8.86 plus 2.4 plus 1.47 plus 0.99. And I get negative 4. So it's two different ways of thinking about it. But your expected value for the group is that every person is going to lose $4. Okay? So, if everybody in the group is like, okay, we're going to go into this and we're all going to buy these tickets, if we're able to buy all 1,000 tickets, we're going to divvy up the winnings back to everybody, everybody would lose $4 by the time they go home. So out of their $10, they'd keep 6 and give 4 to whoever was running the raffle, and that's how that. So that's the expected value of that raffle or whatever that is. So that's how you do expected value. I showed you two different ways, different amounts of winnings depending on whether I say everybody pays $10, 1,000 out of 1,000, or whether I say your winnings are $10 less because you paid $10 to get your winnings. So whatever way makes more sense to you, that's the way you ought to do it. But that's that problem.